So now we're going to try to solve a logarithm. When we tried to solve logarithms before, we liked to have, just a single log on the inside equal to a number, right? Or and maybe there was an expression in there, but we tried to make it not too complex. We wanted a log on either side of the equation. But even then, we'd have a log equals a log. All we have to do is make sure the bases match and then their inputs match. In this problem, we're thrown off by there being a constant not involved in any logarithm. So what we have to do is we have to use these properties that we know. Log base 6 of x plus log base 6 of x minus 9 equals 2. Well, what we know is if we're adding two logs of the same base, then it's the same as the product of their two inputs. And now I've got it down to a single logarithm equaling a constant. I can use the definition 6 squared equals x times x minus 9. Well, this just turns into 36 equals x squared minus 9x. Subtract 36 from both sides. I've got myself a quadratic to solve. Let's see here. The answers to this. Well, it's not a perfect square. I guess one thing I could have done is gone from this spot right here and tried to answer it using completing the square. Let's go ahead and do that. So plus something equals x squared minus 9x plus something to make it a perfect square. Well, 9 divided by 2 is 4.5. I could square that. Never mind. I don't want to do completing the square. Let's do quadratic formula. So you can see how sometimes I try things. They don't look clean. I choose another method that's going to be cleaner for me. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we have 9 plus or minus the square root of 81 plus, what is 4 times 36? 4 times 36 is 144 all over 2. 81 plus 144 is 225. Oh, that's nice. Because I know the square root of 225 is 15. Now, if you didn't know that, of course, you plug it in your calculator and test to see. Square root of 225 is 15. So this is 9 plus or minus 15 over 2. 9 plus 15 is 24, divided by 2 is 12, so x equals 12. 9 minus 15 over 2 is 6, negative 6 over 2, and x equals negative 3. So two possible answers there. I just have to double check to see if either of these mess up my my original functions by making the domain not valid. And the one I'm worrying about is x equals negative 3. Because if I plug that into log base 6 of x, I get log base 6 of negative 3, which is not valid. So I'll just check 12. 12 is good. 12 minus 9 is positive 3, which works. So my answer is going to be 12. This is an excluded value.